Hello, thanks for joining. Today we have day number 22 related to our associate programming or associate training. Today first we'll discuss about the Python program that we left in previous session, and after that we'll go and check BGP. BGP is not part of CCNA training, but BGP is something that we should know and learn about this because it is used in almost all the enterprises. Very much associate level or um, you can say associate level agenda or associate level document I have created. Someone which has very basic knowledge about the routing protocol. For those I have created document that we are going to discuss today after this Python session. And today we'll go and learn only the BGP basics and their theory. Next class means tomorrow we'll perform the lab task related to BGP. All right, so let's start. Last time when we were discussing about different type of Python programs and we started our GNS3, we performed the lab as well. I told you that we have project as well related to these programs. In this project, either you want to configure these devices and these devices are displayed like this, or you can call these devices from some file as well. Either that file is some text file or it's a Excel file. So here you can see that I have one read routers, one function called read underscore routers, where I will go and pass the argument as a router.txt. Now, this operation is very simple that we want to open a file, want to read the file line by line, and in that particular file, the file format, I have one variable that is the IP address. So in this router.txt that I have in the same folder, I have this particular variable that I am calling here in this program. Rest these things are as it is because all the devices they are belonging to iOS, their username, admin password Cisco, and the secret password Cisco. So one function we are defining, obviously this function will go and call within the main function. Now apart from that, what are the configuration we want to push? We want to push the ACL, we want to push the interface, SNMP, AAA. So those configuration as a list, you can see that these are the list of configurations. And within this list, you can see that we have the items. So we have these items that we want to configure. Now, apart from that, you will see that this particular portion that configure router, you can see the configure router portion that is the same that we have in 2, 3, 4 everywhere. We have the same, and then in this we have added the error handling as well. We have added the error handling as well in this. You can see that we are in the try and except block. So we are in the try and the except block. In the exception, we have the netmiko exception, netmiko authentication exception, SSH exception. These are we are calling on top as a package. Netmiko exceptions, netmiko authentication exceptions, they are the connection handler exceptions. So we have added here. Then finally, if you want to take the backup, so in this particular program, the files.py, this is actually the main file, the main um, assignment file where you have everything in a standard format. Then here I have added one more function that is to take the backup. Take the backup for the router in the backup folder. So not only that it will go here, you can see that what command I want to execute. I want to execute the command show run include hostname, show running config, and then it is taking the host name. So from here it will take the host name, and with the same host name it will go and create the backup file. So backup file. So this is something that we want to take a backup as well. And then we have menu based program. So we have menu based program. You can see that I want to display a menu. In that menu, I want to display that 1, 2, 3, 4, 5, 6. These are tasks I want to do. And this display menu. So how many functions now we have? We have one function that will go and read the file, user input file, like router.txt, that will go. Then we have other function that we want to configure the router. Then we have one function that we want to take the backup. Now all these three functions that we have, function 1, function 2, function 3, now we will go to the main function. So you will see that we are defining the main, where we are reading the file first. On top we are reading the file first, and then we are in the loop, while loop, while loop, while loop for this display menu. And from this display menu, we are using one input function. That means it will ask the user that what is your choice. You want to configure ACL for 1, you want to configure the interfaces for 2, SNMP for 3, AAA for 4, backup for 5, like that. And according to that, that will get executed. Then finally, you will see that where we are taking the backup, we are storing the configuration in the backup folder. And 6, option number 6 is to exit. Now all these program that we have, they are in the while loop, means until unless we are giving some input. Until unless we are giving this input, it will not go outside the loop. And once you go and give this, it will exit. The loop will get break, right? And if you do not give any of the option in between 1 to 6, then it will go and throw this error and it will continue. Finally, you have this main. Now, this is one of the project file we have. Same format of file you can be it can be used for SDWAN or DNA. Only thing is this, that these configurations, that they will come as a payload, as a JSON payload. So instead of this list, you have to go and define the dictionary, because dictionary format and JSON format, they are very much the same. So this payload will get changed. These payloads will get changed in the SD-WAN and DNAC program, but logic will be more or less the same that we are using here. This you can think as this is a standard format where you have functions. So same way you will go and define one function to read the files. Same way you will go and define the backup configuration as well. Although in SD-WAN and DNA programs, you have different type of APIs to take backup. You have different type of APIs to do some task, configure some devices, etc., etc. But format will be less or more or less the same, right? And you have to prepare the program like this. Even what we can do in those programs like SD-WAN and DNA program, because they are well supported automation engines. So what you can do on those programs, that even you can create some web application as well, like some HTTP pages and all. And those HTTP pages you can go and integrate with Python. So once you go and execute the program, one web page will come, right? And that web page and URL you can share within the network, like 1.1.1.1 or 10.10.10.10. Some web page you can go and create. And in that web page, we can go and create the user credentials, like user can go and log into that particular website. And then once they log in, then that website will give the option that you want to select router 1, router 2, router 3. Router 1, what you want to configure, router 2, what you want to, like that you can do. So those options are there. All right, so this was the program that is for your reference. First, you can check this menu.py, and then you can go and check the files, because this menu.py, this is a smaller program, and this menu.py program is extended here in this files.py. So this is the extension of this particular program. Okay. You have any question, please feel free to ask. You have any question?
No, sir. I don't have question.
No, Rakesh, this program you will put it there in the share folder, no?
Yeah, last time I shared via the
I need to analyze
chat
it
window.
better.
I will upload there in that share chat.
Okay.
All right, so let's start BGP basics. Today we are not going to perform the lab. Tomorrow we are going to perform the BGP lab. I have created this 3-day training, very much like associate level training, and you can see that agenda. Although in agenda I have added few things related to CCNP as well, but this is very much like basics of BGP. BGP is a big protocol because BGP, and after that you have MP BGP, that is there supported for different address families like IPv6, VPN, V4. You can go and run full-fledged MPLS with help of BGP. You can go and run full-fledged data center DCI interconnection with MPBGP. That is BGP. One of the feature is eVPN, BGP and eVPN. Then you can go and run BGP in normal cases like ISPs. They are using BGP to run their MPLS services within the backbone within the core network. And as a customer, we can go and run the BGP as a C to P connection. See, like my customer edge connection, that how it will go and peer with the provider edge. And suppose in case you have multiple ISPs, then with help of BGP path manipulation feature, we can go and select one ISP over other ISP. Even we have features such as load balancing, load sharing, so we can go and balance the load across different type of ISPs as well. This is one of the advanced feature that we have in BGP. Like some of the subnets you can send via one ISP, some of the subnets you can send via the other ISP. So not only that, the outbound traffic, but the inbound traffic also you can filter or manipulate with BGP. So BGP is one of the protocol which is termed as a application layer protocol, because to run BGP within the autonomous system, within the system, you need some IGP as well. You need some interior gateway protocol as well. And BGP is using TCP port number 179 to run these applications, because this is very much like application protocol. And once it has some IGP like any type of IGP, maybe OSPF or EIGRP or any type of protocol. On top of that, they are running, but it's not like mandatory you have IGP, because BGP itself have their own IGP as IBGP as well, or IGP type of protocol as well. So that can also be used, but BGP is a slow protocol. So that's why generally we are using some other IGP like OSPF or EIGRP, and on top of that we are running the BGP. Right. So let's first of all see what is the agenda for 3 days training. We'll go and check the BGP basics and why we are using BGP terminologies. BGP versus IGP. IGP is nothing but OSPF, EIGRP, OSPF, RIP, etc. Path selection, operations, establish BGP sessions over internal or external autonomous systems, BGP neighbor relationship, different type of messages that BGP is using, basic configuration, then their configuration verification and troubleshooting. That is in day 1. Then day 2, BGP attributes. BGP having different type of path attributes, more than I think 13 attributes they have. We'll see that. What attributes you can see the list here: AS path, next hop, local preference, exit discriminator, MED, origin, community, route policies, filtering. Now these are the attributes. Policy like route map and other policies we have. We can create the policy and apply to the neighbor. how we can do the filtering, how we can create the route maps, the path selections, the route aggregation, what's the use of aggregation and aggregate route advertisements. These things we will discuss in day number 2. Then day number 3, little bit advanced. This is little bit advanced actually, that we have to understand the advanced feature like configurations, route reflections, multipath, graceful restart, scaling techniques, full mesh challenges, route reflections. Maybe I will not cover the lab related to configurations, route reflectors. Multipath is easy. Graceful restart is easy, but these are little bit advanced topics that we have. But we'll see. I I may go and cover one of the lab either. Configuration is little bit more advanced. That this is AS within AS. Route reflection lab we can do easily. It's not a big deal. But even in the route reflection, there are some variations that we can create peer groups, templates, and all those things, which is little bit advanced topic. But I'll try to cover route reflection lab. It's easy to create a route reflections, but when you are tuning that route reflection, then you have to go and measure, take some measures like that. That is little bit advanced. Scaling techniques, full mesh reflection for scaling, again route reflection, the same thing. Consideration for large-scale BGP deployments. These are the theoretical topic. BGP in service provider network, ISP network, peering strategies, and finally the community. Why we are using community? Again, this is used mostly by the ISPs. Service provider, they may have multiple clients and they may have only one router to serve that purpose. So they should not send the routes to different clients, different routes. So there are some communities and there are some filtering techniques that the ISPs they are using to send the exact route to the exact customer. So they should not mix the route within different customers. So those techniques are there with respect to ISP. Let's go back to day number 1. Let's just start with the basics of BGP. What is BGP and their different type of features and attributes? Let's see. So here we are, BGP. BGP is a protocol used for internet. This is a slow protocol. Here you have the topic. Okay, this is the topology I'm going to use. Remember, we have this topology. We have three switches connected, right? And then we have router 11 and router 12. So what we'll do, that all these three switches that we have in our topology, right? We'll make them as a L3 switch. We'll make them as a L3 switch. And then we'll go and assign some IP addresses. You can see this point-to-point IP addresses. We'll go and assign the IP addresses over these interfaces, right? And then we'll go and run some OSPF here. I'll go and enable OSPF as a IGP. So once we have OSPF running here, then I'll go to these routers, router number or switch number 101 and 102. In switch number 101 and switch number 102, I will go and enable BGP. You can see BGP and the AS number, you can see AS number, autonomous system. I will go and use 100. Then you will see that autonomous AS number. Again, I'll go and explain what is AS and all. AS 200 and AS 300. So switch 101 will go and pair with router 11 and switch 102 will go and pair with router 12. Router 11 and router 2 pair. See, within the AS, if you go and enable the BGP, that will be IBGP. And across the AS, if you go and enable the BGP pairing, that will be eBGP. So we are going to enable I, interior BGP, versus E, exterior BGP, IBGP and eBGP. IBGP, eBGP, right? eBGP and IBGP. Again, you will understand that But terminology is easy, term is easy. Within the autonomous system, if we have BGP relationship, that will be IBGP, and across the autonomous system, if we have relationship, that will be the exterior BGP. Again, this is the explanation of the topology that we have, where we are going to perform the lab. This is our lab topology that we are going to utilize. Now you have the basic terminologies related to BGP. You will see that basic terminologies, that what is autonomous system. So autonomous system is a collection of IP networks and routers under single technical administration. So within the single autonomous system, these routers belonging to same AS. So if it is autonomous system 100, where you have the routers, they are belonging to one autonomous system, because we are going to label. We'll tell this router BGP AS 100, router BGP AS 100, router BGP AS 100. We'll go and assign the router BGP AS 100 here. We're going to assign that label here. So that means that autonomous system collection of IP network and routers under single technical administration. That is nothing but your AS number. All the routers and IP network within the same AS, right? Then what is eBGP versus IBGP? BGP session between routers in different AS, that is exterior BGP. BGP session between routers in same AS, that is interior BGP. So that will be the eBGP versus IBGP. Same AS, different AS, right? Then BGP use, what's the use of routing between the AS? That's a BGP. Again, the flavors are IBGP and eBGP. And then you have MPBGP as well, multi-protocol BGP as well. So BGP that is used in data centers, BGP that is used in MPLS, BGP if they have some extended use, that is multi-protocol BGP. So BGP can be categorized in these areas. Then what is IGP? So those protocols that we are running within the autonomous system, such as OSPF, EIGRP, etc., those are IGP. Okay, so far if you have any query, please feel free to ask. You have any query? So here you are running the IGP. Maybe in our case, we are going to run OSPF. And there here you have EBGP. Here you have EBGP. And within the AS, we can go and run IBGP. IBGP. And suppose here also I will go and enable the BGP. So IBGP. Right, this is the AS, this is the AS. Yeah, so far if you have any query, please feel free to ask. Is clear?
Is complex, I guess. Well, for me at least.
Okay, no problem. Once you perform the lab, then you will understand this. So yeah, this is the same topology that we used to use, but earlier we are using some port channel, ether channel and all those things. Just 5 devices we have. Assume that we have only 5 routers, and this is our infra, and this is ISP1. Think that this is ISP1 and this is ISP2. We may connect like this also. So one router having two ISP connectivity, and then we can prefer the routes. Or you may have one router going to one ISP, other router going to other ISP. These ISP, they may have internal back-to-back connection as well. So they can go and exchange the route like this. This route can go like this also, route can go like this also. And then you have here your network will start below this switch or router. All right, let's go and continue the study about this. So now you can see that BGP is using long list of path attributes. You can see the path selection criteria within the BGP. So when BGP has to go and prefer one path with respect to other path, they will go and use the weight. Weight is one of the, these are the attributes of BGP. They can go and use the local preference, the higher local preference that will get selected. Then they will go and check the origin of the originated by the BGP route. The path was originated by the network or the aggregate command. Then they will go and check the shortest AS path. This is very logical. The path which is near, that you will select. Then they will go and check the origin. This is very much related to the AD value that we have. We know that OSPF AD value, administrative distance 110. The BGP, the IBGP AD value is 200. Incomplete maybe 255. So they will go and prefer like this origin type. Oh, so this is more preferred, this is more preferred, and this is less preferred. Like that you have. This is the order we have, but it is selecting the lowest origin type. The lowest origin type may be OSPF will get preferred over IBGP, etc. We can check this point. Then lowest med you can think as a metric value. The lower is better in terms of the med value. Then it will prefer eBGP over IBGP. Why? Because eBGP AD value is 20, and IBGP AD value is 200. So that's why eBGP exterior routes will be preferred over the interior routes. Then they will go and select the lowest IGP metric to the next BGP. Obviously, the lowest metric will be preferred. Then the oldest path will get selected with the lowest router ID will get selected. And finally, if all these conditions are matched, then it will go and check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11th number condition, that a path with lowest neighbor IP address will get preferred. This is the BGP path selection criteria that you don't need to memorize. You just need to understand few of the top items. Generally, we are using local preference, AS path, and med, this one. So we are using number 2, number 4, and number 6. 2, 4, and 6, because you don't need to do this. Anyways, you are running IBGP and EBGP. This selection is auto selection. Anyways, you are running IGP, OSPF, EIGRP. This is auto selected. This is also auto selected. This is also auto selected. This is also auto selected. Where you can go and do the manual changes. Most preferably, we are using the local preference, AS path, and MED. These local preference and MED, local preference, AS path having different type of use cases. We'll discuss about that. But again, in these three, we are generally using local preference and MED, these two only. Where we are using local preference, where we are using the MED to do the path influence, path selection. I will explain you about that. Later on, we'll learn about that in the lab section, where I want to use this, where I want to use this. But this is the path selection criteria. You can see that they have total 11. Actually, I think they have 13 total. And these are the top 11. Generally, those selections are by default, means automatically they will get selected. Generally, we are using only the local preference and MED to influence the traffic. A local preference actually influencing the traffic within the AS, and MED will go and influence the traffic across the AS. That's the difference, but we'll learn about that later on. This is just for your reference. Then BGP operation, they are using port number 179 and exchanging the routing information through BGP messages. What type of messages are there? I think I have one chart for BGP message. Yeah, these are the message types. I'll come back to that. This will be the last slide for today. I'll not go beyond this. I'll come to this point and we'll stop. So now what I try to do here, that I try to make this BGP topic simple, because this is a huge protocol, and you may see 400 500 page books related to BGP. Even I also have shared that BGP book with you. I have shared few books related to BGP. Complete archive of book I have sent, right? I think there you have more than 100 books related to e-books related to Cisco. In that, if you go and see that there are 2-3 books related to BGP. BGP books are there related to BGP, to understand the BGP, how it is working and why it is, and how important all this BGP protocol is. Everything is explained there. So on that, I have taken this very important points, and then we have this in this in our class we are discussing here, right? Even we also have some slides. We actually we have only 38 slides, but if I go and add the lab steps, then our slides will also become maybe 100 page slides. If I go and add all those configuration, this slide deck will become 100. So it's not that I am skipping the things. I'm taking all the main things that you have, but again, I told you that BGP can be used by ISP, and when ISPs they are using it, so they have to go and put so many features in BGP. You have so many features related to filtering as well, like use of regular expression and filter the autonomous systems. It can handle large table, like their control plane can handle more than 20,000 routes. So how we can go and select these 20,000 routes and send only 10 routes to one customer, 10 routes to other customer, 10 routes to other customer, and all those things. Apart from that, how it can go and better utilize the link, how it can go and load share, do the multipathing, provide the security. Everything is there in that. So when you are reading about BGP security, so what security is? So if you read the book, they will go to the history. So earlier this was the security used, then 2000 this security, then 2012 this, then 2024 this, and they will explain you all the features of security. That this security feature will provide this security feature will protect from CPU attack, this security feature will protect from TTL DOS attacks. This security feature will do some MD5 authentication feature, like that. You have all the security features. Then tuning the timer. If you go and read the timer, so why we are using this timer versus this timer versus this timer. All these things you will see in the books, right? Actually, we don't need to learn that much if you are doing some basic operations related to BGP. But if you're working in ISP or in data centers, then you can go and check BGP use in data center, BGP use in service provider. And this is very much like BGP use in enterprise. Okay, now let's see the features related to iBGP and eBGP, interior or internal BGP, external BGP. So iBGP, we know that they are within the same AS. eBGP, different AS. Here AS path is not incremental. Obviously you are within the same AS, so why AS will get added? But in this case, AS will get added. What does it mean? So suppose here I have one more router. Suppose I have one more router here. Let me go and draw. And this router is running within AS 600. Now, when the device will receive the route, suppose there is one network called XXXXXX. This is the network that is reaching to this particular router or switch number 110. Now, when switch number 110 will receive the route, it will see XXXXX, but it will see 600 and then 200, because these are the exterior BGP routes. So whenever these exterior BGP routes, they are getting reached to the other AS devices. So this AS path will get appended. But within the AS, suppose you have one AS and you have 100 routers within the AS, they will not get appended. Across the AS, this AS number will get added. So that's the point it is explained here in the notes, that the AS path is incremented by the local AS number. The AS path will get added hop by hop or AS by AS, not hop by hop, but AS by AS. Okay, neighbor relationship usually formed between the routers within the single AS. Yeah, because you have the routers in the same AS. They are the router in the different AS. The TTL value for IBGP is 255, is huge, like 255. TTL, time to live. Whenever you are going from one router to other router, your TTL is decreasing by 1. And for EBGP, TTL is 1. That means the EBGP neighbors, they are thinking that they are directly connected to the router, right? So TTL is 1. And the moment you'll reach to the other router, TTL will get expired. Advertisement. Routes learned via IBGP are not advertised to the IBGP pair to prevent routing loops. So IBGP to IBGP routes are not getting advertised, but routes learned via EBGP are advertised to all the BGP pairs, both EBGP and IBGP. So they are advertising the routes, they are not advertising the routes. Typical use case, use for routing within the AS, use for routing across the AS. This is internal, this is exterior. Then route propagation require full mesh, or you have to go and use the route reflections or configurations, AS within the AS. So this IBGP, actually this IBGP having routing loop issues. When we are talking about IBGP, they have routing loop issue because the routes that they are not actually, the problem here is this. Let me explain you the problem. These routes, you can see these routers here. Let's understand the problem. Suppose I have one more router here like this, and this is connected here, and this is connected here. And this router having route, suppose 3.3.3.3. Now, when this edge will get 3.3.3.3, so it may advertise to this direction also and this direction also, right? Now, when he has to get this 333, which link it should use? This link or this link? So that's why we have seen this, that IBGP peers, they are not advertising their routes internally to protect from the routing loops. But if you have more routers, at the moment you can see only 3 routers, and later on you will see that to form IBGP relationship, you don't need connection. You don't need physical connectivity. If you have routing reachability, they will form the relationship. So if I have one router or switch here, and if I have connectivity like this and like this only, I don't have this connectivity. Suppose I don't have, this is not there. That doesn't mean, suppose this is switch 550. That doesn't mean that 550 cannot go and form the relationship with 110. They can form because you have some IP reachability. You have reachability via OSPF or EIGRP, etc. They can form. And since they are not propagating the AS, because all these routers, they are part of same AS. So it's very difficult to protect from loop. So there are chances that the routes that I am getting, I can advertise to the same routers. So routes I am getting from this router, I can send to these routers as well. So how they will understand that this is the route I am advertising and I don't want to receive it? There is no such mechanism in IBGP. So that IBGP is very much like loop prone. They can form layer 3 loops. That's why we are using different type of methodology. For example, route reflection, RR. So in that, what we are doing, we are making one of the router as a root, one of the router as a primary router. Now this is the responsibility of this router. Now if this is the router is responsible, he is the primary router within the RR, route reflection. So he is the primary. So now his responsibility is this, that he will only learn all the new routes and only he will advertise the routes to all his peers. So in that way, you can go and protect from the loop, because only one router is the primary router and he will learn the routes and he will advertise or refresh the routes for the other routers. Now you may think, if this will go down, what will happen? If the primary router will go down, what will happen? In that case, you can go and create multiple RRs, multiple route reflectors. So that's the point explained there in that, that's the listed point here. The use case that IBGP requires full mesh or the use of route reflection or configuration. Either you use full mesh to protect from the loops or use the route reflections or configuration. If you are using full mesh, and suppose if you have 200 devices in one AS, it will choke down the bandwidth. So that's why we are using the either route reflection or configuration. EBGP, it's simple, directly advertise their routes. AD distance, you can see here, the AD distance is 200, is huge. It's a big number. That's why OSPF can be preferred or EIGRP can be preferred over IBGP. But for EBGP, the AD value is just 20, 2020. It's less, it's more preferred. Multi-hop, often used with multi-hop BGP configuration for redundancy. Typical of multi-hop is used because within the one AS you have multiple routers and all. It is assumed that you have only one hop away. That's why the TTL value is 1. Time to live value is 1. Configuration is very much same, like how you can do the configuration, that we will see in the next class. But generally, suppose if you are in router 11, you can go and enable, say, router BGP 200, and then you will use this neighbor command. Neighbor, suppose 111 is my neighbor, and then you will give remote AS 300. Now this is the example related to, if I give 200 here, that will be example related to IBGP. See, you are in the same AS and your neighbor is in the same AS. So this is the example related to IBGP. But if you are writing the example related to eBGP. In that case, we have to go and write like this, say router BGP 200, and then for example neighbor 444, remote AS 400. So in this case, you will see that your remote AS is different and your own AS is different. This is example for eBGP. Right. Then the last slide for today's session. Yeah, we have lab related to this. So in the lab, we will see that eBGP will form the neighbor between the different AS, iBGP within the same AS. Then you will see that we have the message type in BGP. Open, update, notification, keep alive. Open means that when you go and start configuring BGP, they will send the open message that, hey, this is my BGP configuration. I am sending my BGP open message. I just wanted to establish a relationship, BGP relationship with you. So then it will send the open send. Actually, there are more messages type. I haven't added here. Actually, open send, open confirm, like that. Some more messages are there. I have listed only the top messages type here, but more messages types are there. Then update, advertise new routes, notification, indicate an error in the BGP. Suppose your AS number having wrong format, your BGP having some issue. Like the notification means something is wrong and then it is sending the notification. Keep alive, just you want to check that BGP is up or not. It is live or not. So you are sending the keep alive message. You're checking that their neighbor BGP, they are up running or not. These are the important messages. Top open message is something that will check that BGP session I want to create, and I'm sending my open message for negotiation, that my peer also will receive this open and confirm me that open, he has the open, that he also have the BGP configuration, so we can form the neighbor relationship. So for that reason, we are using the open to establish a BGP session. To update the new routes, if we are advertising new routes, you can go and use the update message. If something is going wrong, you will get the notification, and keep alive is a message just to check that the peer is active or not. So these are the important message types we have in the BGP. Thanks for joining. Today is day number 2. This is day 2 for BGP. And in this day number 2, I think overall we are in day number 23 or 22. Unable to recall that, but this is day number 2 for BGP. And today we are going to perform one small lab where we'll go and form the iBGP relationship. So in this autonomous system, AS number, I'll go and run one of the IGP as OSPF. And on top of OSPF, we'll go and run the iBGP, interior BGP. Then across the autonomous system means AS100, AS200, AS100 and AS300, we will go and enable the eBGP. So iBGP and eBGP, these BGP we are going to execute, and after that we'll go and verify that. Now before starting that BGP configuration, we have to go and assign the IP addresses. Like this, you can see that we have this type of IP schema. So suppose if this is switch number 110, I will go and assign the IP address 192.168.100.110, and this is switch 101, so this will be dot 101. Like that, this will be 101.110, and this will be 101.102. Like that, IP schema I will go and assign, and then over these interfaces, and these interfaces. So let's go and assign this IP schema to these interfaces. Let me go to switch 110. And in this switch 110, we know that this is working as a L2. So I will go and default the interface E1/0 and then interface E1/0. No switch port, so it will become L3. And then the IP address 192.168.100 dot. This is 110, switch number 110, like that. And then the subnet mask 255.255.255.0. The other interface we have, so that also I will go and default interface E1/2, and then we'll go to E1/2, no switch port, and then the IP address 192.168.101.110.255.255.255.0. Do show IP interface brief. You can see that these IPs we are assigning to the interfaces. They are up. This is also up, right? Likewise, we'll go to the other side, other switch. And this switch, we have default interface E1/2. This is connected with switch 110. No switch port. Interface E1/2, no switch port. And then the IP address 192.168.100.101. Make sure that we can ping to the other side, that is 110. That is the point-to-point link. And likewise, we have other interface. So let me go and default the interface E0/0, which is going to the router number 11 as per the diagram. I'm just following this diagram. So then E00 is going to this interface. So interface E0/0, no switch port, and then the IP address 192.168.200.101.255.255.255.0. Oh, I need to go to that device and then I have to go and assign the IP address. Likewise, you can go to switch 101, E12 and E00. So I can go and default the interface E1/2, default interface E1/2, and then E00, and we'll assign these IP addresses. So let me go and do that. And then they default the interface E0/0. Let's go to interface E1/2. No switch port, IP address 192.168.101.102. No shut, and let's ping to 192.168.101.110. And likewise, we'll go to interface E0/0, no switch port, and IP address 192.168.202. You can see the IP here, 202 dot the switch number 102. Then the router number 11 will go, and router number 11 interface E0/3, that is going to switch 101, IP address 192.168.200 dot router 11, so I'll use dot 11 0, and then interface E0/1, the IP address 192.168.201.11. No shut. Simply we are assigning the IP address as per the schema that we have. Then router number 12, one interface, that is interface E0/3, that is going to the switch 102.202.12, that's the IP, and then finally E0/1, IP address will be 192.168.201.12.255.255.255. Let's try to ping 11. Try to ping 11, that is a spear. Oh, this IP is incorrect. The peer IP is switch number 102. Some wrong IP assignment, no problem, we'll go and verify. So in between switch number 102 and a router number, oh, IP address, instead of 192, I put 102. Oh. So it should be 192. And let me go here. Now you can see it is pinging. So from this side, it's okay. Let me try and ping to this side. The other router should have this point-to-point ping working. So pinging to the switch 101, and let me try to ping to the peer, that is 12. Okay, so now we have full-fledged IP schema. You can see here the diagram. As per this diagram, we have assigned the IP addresses over the interfaces, right? So first of all, I will go to this particular router, these switches actually, and there I will go and enable the OSPF. Once we have OSPF, full-fledged OSPF up and running, then we can go and enable the IBGP and BGP. What configuration we should do? So let me show you the configuration as well. Once you assign the IP address, then these type of configuration we will go and do. So let me pull the server and the configuration. Okay. So here we are. What we want to do now, that we want to run some IGP. So I can go to router OSPF1, for example, and I can go to interface E1/0 IP OSPF1, suppose area 0, and then I can go to interface E1/2. I can run the same. Likewise, we can go here. You can see do show IP interface brief, include 192. This is the IP that we assigned. Oops. Router OSPF1, then we can go to interface E0/0, IP OSPF1 area 0, interface E1/2, and IP OSPF1 area 0, like that. Then we can go here to switch number 102. Do show IP interface brief, include 192, because 192 IP address range we have assigned. So router OSPF1 will enable the OSPF, and then we can go to interfaces. IP OSPF1 area 0, interface E1/2, IP OSPF1 area. So like that we can do. Now one thing here is this, that even we can include the loopback addresses as well, that I'm not adding, but we can go and add that also. Do show IP route OSPF. Now we'll see that 102 is receiving 100 route. So if you go and refer the diagram, that is in the slide number 7. So now 102, see this we don't have the IP address. This is directly connected interface. So obviously it will go and receive this particular route, which is correct. Likewise, 101 will receive 101 route, right? So we can go and verify that. And we should add loopback as well. Generally, if you see this configuration, I'll tell you why we should go and add the loopback as well. So let me go here and add interface loopback 0 and this and interface loopback 0 this interface loopback 0 do show IP interface please. In this we don't have any IP over the loopback, but let's see here. Do show IP interface brief loopback 0 10.1.255.101. Likewise, I can go here to interface loopback 0 and I can assign IP address 110.255.255.255. Let's see. Do show IP route related to OSPF. I will see that they have all those OSPF route. The other interfaces they have it is receiving the route from router number 12, 13, etc., etc. Some other routes from the other data center and all. And it is receiving the route from 101. This is switch number 101. This is switch number 102. These are the loopback interfaces via these interfaces that we have assigned. So now we have the full-fledged OSPF, which is up and running as a IGP. Now we can go and do the configuration related to BGP. So here you can see the back. I can go to, let's just start with switches. Switch 101.1.0.101, etc. So you can see these switches. Oh, this is wrong actually. We should have IP in the same range. So if I am in 100 and I want to pair with 200 and 300, we should go and refer the diagram. No problem. Let me go and show you the diagram. As per the diagram, I will go and configure. So here we are, and we can see this. Now you'll see the steps. I can go to router BGP 100. So I'm a starting router BGP autonomous system 100 for this particular switch. Then we can go and simply give who is the neighbor, who is my neighbors. So let me go and draw the diagram here. We know that we have three routers or three switches. So
Should be the
110,
other two.
yeah, 101, 102 like this, and we want to create the IGP. Here you have 101, and here you have 102, and connection we have. In this interface, I have not assigned any IP address. So this and this, right? And as per our topology and as per our diagram, I should go and assign the neighbor relationship. So who is the neighbor? 110 to 101, 192, 168, 100.101 is my neighbor, which is in the remote AS. which has the same remote AS 100. At the moment, we haven't enabled that in 10101, but we'll do that. Likewise, we have other neighbor 192.168.101 dot, who is my peer 102, whose remote AS is the same. When you are doing this configuration, generally we are using one more command in this: update source loopback 0 and update source loopback 0. Now this is the full configuration related to the BGP. You can see that we are in the AS100 and we want to create IBGP relationship with two of my peers. Likewise, I can go to 101. At the moment, I want to create just the IBGP, so I will configure only one portion. Now this is connected with the router, and we have the connectivity like this, and then we have connectivity like this. Now here this is router number 11 and this is router number 12, right? So this part of connectivity, this part of connectivity should be IBGP. So this connectivity that we have here, this is this is EBGP, and this part of connectivity is IBGP. So here we have everything here we have IBGP, and here we have obviously two-way arrow, not only one side, from here to here and here to here. Why? Because this is in different AS. This is in AS 200 and this router is in AS 300. So there we have to go and form the EBGP, right? So if we are in switch number 101, I can go and create, I have to go and do two type of configuration. One is for IBGP, one is for EBGP. Like that we will do. So now I can go here to router OSPF, router BGP 100. We will enable the BGP. Then my neighbor 192.168.100.110. This is my interior neighbor whose remote AS is the same. And then for this neighbor, I can go and do update source loopback 0. Then I have the exterior neighbor whose IP is 200.11, but the remote AS will be 200. As we know that the eBGP TTL is just one, and IBGP TTL time to live is, what is that number, 254 or something, more than 200, 254 or something. So that's why you can use these commands, update source loopback. There is no problem in that. But for IBGP relationship, generally we are not using update source loopback, etc. We'll go and do the configuration like this. Now we can go and check do show IP BGP, just to do show IP BGP summary, just to show you that with the interior neighbor, this should be up. You will get the message that this is up and running. Anyway, this side of BGP configuration we haven't done, but this side of BGP, you can see idle, active, open send, open confirm, those type of messages will come, and this, it will show you that I'm up and running. Do show IP BGP summary. BGP generally is a slow protocol to converge. IP BGP. active open failed, active sent to active to idle. Why it is failing? So it is telling that local address is this, connection refused. It's telling that BGP connection is refused. BGP is getting refused. Why? Because they have some address mismatches. Active to idle, open time running, active failed, open time running. TCP is not. So you can see clearly that they are unable to form, they are not forming the BGP relationship. I will come back to that. We'll try to troubleshoot that. Now let's quickly go to router number 11, where we have the BGP. Okay, one BGP portion is running, so I'll turn that off. I'll enable my BGP, and whose neighbor is 192.168.200.101 with the remote AS of 100. And then there is one more neighbor, 192.168.101, and 12. Remote AS is 300. Right, here you can do show IP BGP summary. Now you can see that this is a you can see this BGP is no problem. This is up and running, but we have some problem with IGP, and we will troubleshoot this while this is going down. Let's go and complete the entire configuration. Likewise, I can go to switch number 102 and router BGP 100. Who is his neighbor? His neighbor is 192.168 and 101.110, and remote AS is the same. Then I can go and go to the other neighbor 192. Even in this neighbor also I can go and do update source, look back 0, then neighbor, the exterior neighbor 192.168.202.12, and yeah, you're telling
300.
something. 300,
Yeah,
right?
no, 12 and 300, yeah.
And then final router, let's go and do this router BGP 300. What is the, oh, no, router BGP 65001. And then the neighbor 202.102. And the
200.
remote AS is remote AS is 100. And then finally, neighbor 192.168.201.11. Remote AS is 200. Debug IP BGP. Debug of IP BGP. Now we can go and check show IP BGP summary. Oh, they are up actually. Go to router BGP 300 and the neighbor command is there. Shut down. Now, if it is shut down, you can see that different type of messages that we can see that the active open failed. And if you go and do the remote ACE What is that? Remote is 200. This shutdown. If we can do no shutdown. Moment will do no shutdown. It is coming up. I just wanted to show you the. So here actually you can see the messages type as well. So BGP, they are sending the open messages to form the neighbor relationship. Then you can see open send, open confirm. Within open itself, they have different type of messages. Open send, open confirm, and then establish. So open is a message. They start sending the neighbor packets, and then it will move to open send and open confirm, and finally it will be in the established state. It will get established. Now let's go and troubleshoot the iBGP and debug all. And now you can see that so IP, let me see the loopback 0. Show run interface loopback 0. What's the configuration? So configuration here is this. And let me do one thing. Clear IP OSPF process. Show IP OSPF neighbor. Clearing the OSPF process so they can go and form the OSPF process with their router ID. Let me go and clear IP OSPF process. Oops. Yes. And do show IP OSPF neighbor. OSPF neighbor. Still I can see that they are forming neighbor relationship with the IP addresses that we have assigned. Okay, no problem. Ten dot 1.255.101 and OSPF1 router ID 10.125.102 IP OSPF process. I'm just forcing them to use the loopback address to form the neighbor relationship, but I can see that they are not using it. Although I have used this router ID. So if you have such type of router ID, then the OSPF should go and use the router ID actually to form the neighbor relationship, but you can see it is using the directly connect link. So what I can do more here, that I can go to, let me see. That's why we can go to these interfaces E0/0, IP OSPF1, IP OSPF network point to point 1/2. We make these interfaces as a point to point. Show IP interface brief. Include 192. Interface range E0/0, E1/2. IP OSPF point to point. Show IP interface brief. Include 192. Interface range E1/0 and E1/2. And then we can clear the process. Clear IP OSPF process. So the OSPF will get restarted. So now I can see here that for switch 110, it's okay. They are using the neighbor ID as a loopback address. And what about this? Still it is not showing that, but no problem. It's okay. Some EVNG related issue. It should show you some neighbor ID here, which is not showing, but it's okay, no problem. Now we have made this point to point. Let's go and see that. Is there any effect? So IP BGP summary, that's the command. You can go and see. Now I can see that my IBGP relationship is not forming due to any reason. It is not forming. Generally, it will form if you have the reachability. If you have this reachability, they will go and form. Why it is not forming? Clear IP, or let's do this thing. Yeah. Clear IP BGP star. This is the aggressive restart of BGP. This is aggressive mode that we are restarting the BGP. This is not recommended that we should go and use this command. Forcing the BGP to reset their neighbors. And then we have the soft as well, like you can go and use soft clear IP BGP. Neighbor, whatever neighbor you have, you can see that soft restart is also there. Maybe it will not come here. Let's go to router number 11, BGP, and you can give the BGP neighbor address, for example, 1.1.1, just showing you that we have, yeah, you can see the soft. So this is something that is less aggressive. Soft reconfig inbound, outbound. So you have in and out option here. After soft, you can see that in, out, slow, enter. Enter means that in and out both. So you can do the soft refresh of BGP. This is recommended that you can do it, no problem. Or if you want, you can do this aggressive, but this aggressive is not recommended. I can clear IP BGP star. That means everything will get refreshed. So you don't want to refresh the BGP table because they are huge. And if you do that, then entire network will get destabilized. So better you pick the neighbor and only those neighbor routes you can restart if you are occurring any problem. Okay. So let's see the configuration. Why my IBGP relationship is not working? At the moment, I'll go and remove this update source loopback, these commands. And these commands I'll go and remove. Likewise, I go and check show IPv6 summary. With router number 11, this is up. Router BGP 100, section BGP. Okay, I'll go and remove this. Now you can see that one side it is up, other side is still it has some issue because of this update source loopback configuration. So we'll go to 101 section BGP 100. No, I'll remove this command. Now probably you will see that it is up. You see both the neighbors are up. We have removed this update source loopback command. We're giving that command generally when we have the full meshed configuration where you have this peer also up and running. This interface is also up and running. Or what we can do, so let's go back to the configuration with 10, for example 102, and neighbor 1. Okay, no problem. This neighbor. What other things we can see? See, so many options are there. Activate, advertise, allow policy, allow AS in, accept AS path with my AS present in it. AS override, capability, origin, description. My God, so many follower, HA in local AS. Timers, transport, TTL security. If you want to tune with the TTL value, you can use that. Update source, version, wait. Wait is something that will be used for path manipulation. This is for summary address you want to unsuppress. These are some advanced features you have. Shutdown, we have just seen that. Send label and all. You can see how many options you have. Even if you go to one option, inside that you have some more options. So basically we have issue here related to that loopback address that we have. Rest everything is okay. So it's okay at this point of time. Otherwise, what we are doing, that when we have the full mesh configuration, we are enabling some sort of route reflection. I will see that agenda. If that is there in our blueprint, I will configure that as well, but it's okay. It's not a big thing. That we can go and verify. Let me quickly go here and see what are the things we have. So likewise, you can do the configuration. Even I can go and advertise some network as well. So that I will do now. Network advertisements we can do. Neighbor and remote AS. We can go and check show IPBGP summary. Show IPBGP will give you the uh, BGP table. So what is happening here, that BGP, they are forming 3 different type of tables that you can see. If you want to see the neighbor table, you can go and run show IPBGP summary. Will give you the neighbor table. If you want to see the BGP table, they are forming 3 table, right? Neighbor table, BGP table. Then you can go and run show IPBGP. But if you want to see the routing table, then you can do show IP route BGP. So 3 different tables the BGP is forming. The neighbor table, the BGP table, and the best path will be in the routing table. 3 tables are there that we can go and verify. So let me show you all those 3 tables. We can go and check the show IP BGP summary. This is nothing but your connected neighbor table. Then you can go and check the BGP table. Nothing is there in BGP table. Why? So let me do one thing. Let me create one loopback 10 with network 10.10.10.10 and IP address 10.10.10.10 and then router BGP 10.10.10.10 mask. I am advertising that in BGP section. Okay, do show IP BGP. So now you will see that it is coming in the BGP table. Next hop is 000. Why? Because this is self-generated route. If I have self-generated route, their next hop will be 0 because I am generating. So that's why next hop is 0. But if you go to any other peer router, so IP BGP summary, you can see the BGP table like this. So IP BGP, and you can see it is receiving one prefix. What is that prefix? So now if you go to show IP BGP, you will see that next hop is the switch number 110. It is receiving this particular route. The star means best, selected, I means from the interior BGP, IBGP. This is the route which is coming via 110. It is receiving from 110, whose metric is 0, local preference is 100, weight is not set, 0, actually 0, and path is I. It is learning from IBGP. If it will learn from IGP actually. If it is learning from the redistribution, then you will see this question mark. If it is learning from EGP, you will see the E here, the code. These are the codes here, right? So likewise, you can see these 2 tables. You can see the show IP BGP summary, the neighbor table, show IP BGP, the BGP table, and show IP route BGP will give you the routing table. You can see B stand for BGP. This is the network which is coming from the interior BGP. That's why the metric value is, sorry, the AD value is what? The AD value is 200. We have discussed about this thing, that if it is learning from the exterior BGP, then this will be 20. Let me show you that. If I go to router number 11, and if I create one loopback IP address 11.11.11.11.255.252. If I go to router BGP 200, and if I go and advertise the network 11.11.11.11 with mask 255.255.255.255, and now if you come here to 102, and if you see this route, you will see this 20. Why we have 20? Because this is IBGP learn route. Sorry, this is EBGP, exterior BGP learn route. And we know that for exterior BGP, the AD value is 20. For interior BGP, for IBGP, the AD value is 200. So you can see 20 here, and you can see 200 here. And even we have discussed about this thing, that the EBGP will be preferred over the IBGP. So if I come here and if I see all those 3 routes here as well, so IPBGP summary, this is the neighbor route, and then show IPBGP. Now you can see that it is learning. So switch number 110 is learning this 11 route from 202 from router number 12 and router number 11, but from router number 11 this is the preferred. You can see a star and greater than, that means preferred route. This is the backup. Why it is so? Can you tell me the reason why this is preferred route and this is the backup route?
No, not sure.
Okay, so what we have done, let's try to understand that and then I'll ask you. So what we have done on which router? Router number 11, right? Router number 11, we created one loopback and we have advertised this network. Now this network is reaching in this direction and in this direction
Oh, okay, okay.
via this path, via this path. So via this path, when it is reaching, it is the preferred one, but via this path, it is less preferred. Why? Because you will see here clearly in the output that this path via 202, it has this AS and this AS. It has more number of autonomous system. And via this path, it has only one autonomous system, 200. More AS means that will be less preferred because it has to go past more number of autonomous system. This is the best path selection criteria that we have discussed earlier. So if you go and check the best path selection criteria, you will see that prefer the path with the shortest AS, right? That's why it is doing like this. That's why it is preferring this as a best path because it has only one AS prepended 200. Here it has two AS. Right? So let's go here to slide number 15 and 16. You have configuration and verification. Then you can go and check the neighbors. We have done that checking. Then you can check you can ping the neighbors, you can check the neighbors, the BGP configuration, the updates. We have done that. Then you can ping, it will reach, no problem. Ping and all these things will work. BGP debug also we have done. So we have completed part 1 of the section 1 of the BGP. And we can stop here. Yeah, what is the question?
So the question is, what happened if the link between switch 11 and the switch 102
This will go
goes
down.
down?
So let's do that. Let me go and that. Okay. So what we can do here is this, that the link between switch 101. So I can go to interface E because this is the preferred path, right? So let's see, first of all, the preferred path is via 200, this link. So let's go to switch 101 and E0/0 and shut down this link.
Yep.
And then let's see that how the BGP is reacting. So now you can see that this is becoming the best path. Now
The
we
best
don't
part, the primary.
see the backup now. Earlier we have two paths here. I can
Yeah,
see
we
we
have
have two paths here. And this is the best path. Now since this the link is down, so BGP got converged. And now this is becoming the best path. Now you can see the greater than and asterisk here.
and question there, what configuration is doing that change? Is the loop back? Uh, the one is doing
No,
this
we have
change?
the BGP configuration. That's it. BGP is taking care of that. We don't have
Okay,
any loopback here. I remove all the loopback configuration. Okay.
okay.
A loopback is there, functional there, when you don't want the we don't have the dependencies on the physical interfaces. So at that time, the loopback will come into the picture. If any interfaces are going down, since you have the IP reachability, loopback will take care. So even for BGP also, we can go and assign the router ID. So if you go and check the show IP BGP neighbor, let me see the full show IP. Let me show you that. Show IP BGP neighbors. And if you see this full, so you can see that neighbor is this, yeah, router ID is this. So BGP is depending anyways upon the loopback address as a router ID. So any physical interface will go down. There is no impact on the BGP part,
Mm.
right? So BGP has those type of inbuilt capabilities, features, so they can resist. Right? Do you have any other question?
No, I don't have any other.
All right. So thanks for joining. Today, BGP day number 3. And today we are going to discuss about some more features within BGP. You can see that we have BGP attributes such as AS path, next hop, local preference, MAD, origin, community, BGP route policies, route filtering, influencing the BGP path selection, aggregation, etc. So these are the topics we have. We are going to do a small change in our topology. Last time we have switches 101, 102, 110 in same AS, and then we have router 11 and router 12 in the other autonomous system. But today, assume that we'll go and create eBGP relationship in between switch number 101, 102, and 110. So switch 101 is part of AS 200, 102 is part of AS 300, 110 is part of AS 100. And then router 1 and router 2, they are part of same AS. So here we will go and run the IPGP, and then we'll go and learn these technologies, right? So let's start. Clean the diagram. I can see that AS path is something that will help you to prevent the loops. Why? Because if we have AS path and if you are in the eBGP relationship, so eBGP routers, they are preserving the AS number. So they will come to know that they are coming via high number of, or they are passing via high number of ASs in between or low number of AS paths. If it is coming via low number AS path, that will be preferred. So that means that will be installed in the routing table. In that way, they can go and protect the routing loops. That we have seen in our previous session, that one of the route is coming via two AS 200 plus 300, and one is coming via AS maybe 200. So AS 200, because it has only one AS to pass, it was preferred. But once we have shut down one of the interface, that AS 200 was unreachable, then automatically that longer path, that path and the route related to that path get installed in the routing table. So that's the AS path. It is providing the loop prevention mechanism within the BGP. Next hop is just the subnet, and what will be the next hop. So if you are generating the route, what will be the next hop? 0.0.0.0. Right, so that's the next hop. Local preference and MED, these two things are very important, and generally we are using these, and that's why I have created chart as well. In the upcoming section, you will see, upcoming slides, you will see that I have created the chart related to this local preference and MED. Local preference is an attribute that is within the AS. There are differences as well. Local preference is within the AS, and MED, they are influencing the traffic within different AS. That's the key difference in between that. This is a feature that is assumed that will affect the traffic within the AS, same autonomous system, and this feature will go and affect the traffic outside the AS. I have one nice chart. I will show you in that chart. The other difference, that local preference higher is preferred. MED, like metric values, lower is better, lower is preferred. So differences are there in this local preference and MED. Origin means who is originating the route, who is the actual owner of the route. Community, that BGP having this tagging mechanism that they can tag the routes. When we are dealing with MP BGP, multi-protocol BGP, at that time these communities are becoming very important, because in that case you have to import and export the route. So you want to tag the route and then you want to import and export it. So probably this feature I will not cover in CCNA level, but this is a useful feature when we are learning MP BGP. Filters, yes, you can create the prefix list, access list, and then you can map that with the route maps, and then you can apply to the neighbor. So access list, we know that how we can create the access list, but then you can create the route maps. Route map is also one feature. Basically, we have this feature in the CCNP level, where you have the route map policy. This is nothing but policy in sequential manner. Like sequence 10, you can write something, sequence 20, you can write something, sequence 30, you can write something. And then you can go to neighbor 11111, and then you can apply the route map to the BGP neighbor. I have example today as well. I'll show you that. Then BGP policy related to route map, and then the path selection using MED and local preference. I will explain you that in the upcoming slides. If you want to summary the routes, you can go and use the route aggregation. You can do the aggregate address command just to summarize the routes. Why we are doing the summary of routes? So if you are sending the summary routes, then in that case, the router will not go and scan the entire routing table, but from the summary, it will give you the result. Right. Now you can see the difference in between MED and local preference, because these two are very important, and generally these two plus AS prepend, these only 2-3 features we are using. So you can see that MED, I already told you that it is related to multi-autonomous system, exchange between different AS, and local preference is within the same AS. Exchange only within the exchange route, only within the same AS. Influence the traffic from external. This is actually very important. That influence the incoming traffic, MED. They are influencing the incoming traffic. So when you will apply it, you will apply it in the outward direction. OU2, whenever I will apply it to outward direction. and this is influencing the outgoing traffic. So when you will apply this, you will apply into the in direction. How it is, how we are doing it, I will show you that. So you will apply to the in direction, or let me quickly show you in this diagram. So we have one diagram. Let me go open that diagram. So here you can see this diagram. This is a small diagram that we have. Now, if we go and influence the route, so if we are applying the local preference, so suppose if I go and apply the local preference, I have to apply to router number 11 that is coming inward, inside. I will apply it to inside. What is the effect? The effect is outgoing traffic. But where you will apply? In direction, inward direction, inward direction. What changes it will do, I will show you in the lab. Then here the MED, MED influencing the incoming traffic. Incoming traffic, that means when you apply MED, you will apply in the outward direction. OUT, it will be applied to the outward direction. Outward direction influencing the incoming traffic, influencing the outgoing traffic, you will apply in the in direction, just the reverse. This and this, they are very much working in the reverse manner. MED, lower is preferred. Local preference, higher is preferred. Default value 0, default value 100, that you can change it easily. Use cases, I will show you the use cases, but you can go to the route map and you can set the local preference, set the metric, etc. Configuration is easy. Use cases are this, that we can influence the route. If you want to influence the route, then you are using it. And what's the use case? Today I will show you in the lab. Now you can see that we have a use case related to this. Let's understand this use case. What exact use case we have with the local preference and the MED. Let me clear the diagram here. Okay. Local preference to influence the outbound traffic from AS 100 to prefer the specific exit towards 200, 300. Suppose you are one of the router and you have two ISP connected, ISP1 and ISP2. You want to prefer ISP 200 over ISP 300. So what you will do, you will go to ISP 200 neighbor, and there you can give local preference, for example 999. By default what it is? By default it is 100. If you give more than 100, 101, that means that the AS towards AS 200, the local preference is 101, towards 300, default is 100. So that means AS, ISP 200 will be preferred. Very easy. Very easy, right? So in our diagram, if I go here, oops. Let me get my diagram back. Let me try it. 1, 2, yeah. So in this, you can see in this diagram that you have this exit and this exit. If you want to prefer this particular exit, then here you put more cost, more local preference. Suppose 101 is more than 100, so this exit will be preferred. Likewise, use of MED to influence the inbound traffic from AS 200 and AS 300, prefer a specific entry point. So MED will also do the same thing, but that will be applied to these different autonomous system, because anyways these are the ISP network on top. You can't do anything in the ISP network. Whatever changes you can do in your routers. This green rectangle is your routers. This is your company, and these are the ISP. AS100, AS200, AS300. These are the ISP. I can't do anything there. So when you apply the MED and you want to prefer this with respect to this, lower the MED value, MED value, and then this exit will be preferred. Higher the local preference, this will be preferred. Lower the MED value, this will be preferred, like that. Let's see the lab configuration. So here you will see the lab configuration. Although in our lab, we are going to do some changes here. Right? Why we want to do the changes? Because we have changed the topology here. Now router 11 and router 12, they are part of same AS 200, 300, 100, 200, 300, where we'll go and form the eBGP relationship. So before coming to this particular configuration, let us set up our lab. We have the IPs configured over the interfaces. What I have to do, I have to go and create the eBGP and iBGP relationship. So let's open the lab pod we have. I just done the route IP configuration. So switch 110 is part of AS 100. What are their neighbor? Neighbor, you can see the neighbor 101 and 100. So this is the neighbor, right? Which is in the remote AS 200. And then it has one more neighbor 101.102 remote AS 300. Then we'll go to 101. This is router BGP 200, and the neighbor, one neighbor is surely this, and remote is 100, and then the other neighbor, which is the router 11, which having remote is 400. Likewise, I can go here, router BGP is part of 300. Yeah, and then the neighbor, who is the neighbor, one neighbor is 202, that is the router number 12, remote is 400, and one neighbor is 101.110, which remote is 100. Then we'll go to router number 11 is running this. Oops, no, router BGP 65001. We'll go and already running. Okay, and then the neighbor 12. This 12 is what? This 12 is the same as, and then what is the other neighbor? 200.101. Okay. So this is in the AS 200. This one. Then here we are. Let me remove router BGP 65001, router BGP 400, and then the neighbor. Who is your neighbor? Within the same AS, and then it has one more neighbor, that is this one. within the remote AS of 300. So what we have done that as per our diagram, we have set the BGP relationship. Let's see. Do show IP BGP summary. And what you can do that you can create the shortcut as well, alias exact show IP BGP SIB, show IP BGP summary or show BGP summary or you can SBS or maybe SB or SS, show BGP summary, show IP BGP summary. And then if you go and type SS, so you can see the result. Right, so all the places you can see that BGP is up. You can see the BGP is up. Do SS or create the alias, and everywhere you can see BGP is up, but nowhere you will see that they are sending, receiving the prefixes. So what I will do here, I'll go to this router, this switch 110, and here let's do one thing. Say interface loopback 11, IP address 11.11, and then router BGP 100, network mask. And now if you go to router 11 or router 12, and if you see show IP BGP, say suppose this is do SB. If I type SB, space, okay, I should do like this. Do is not, they're not taking do. Okay. Okay. So now you will see that they are receiving the route. So here I created one network, say 11.11.11.11 within the AS number 100. Now that network, because since here we have the eBGP relationship, here we have the eBGP relationship. So this router, how it will receive the route in this direction and from this direction. So here it will come to AS 200 and AS 400. Here it will come to AS 300 and AS 400 and this. So you can see this. It is coming via 300 and 100, receiving the route from 202, 102, 102 means uh, router 11 is receiving the route in this direction and in this direction. Which is the preferred one? The preferred one is in this direction. You can see why? Because this is the best path. The asterisk greater than is the best path. Why? Because you can see best, valid and best. Valid and best. So this is getting installed. This is getting installed. BGP algorithm has done this. It is installing in this way. That's okay, no problem. Now I'll do one thing. Let's go back here and create one more route and advertise to BGP. For example, 12, 12, 12, 12, interface loopback 12, IP address 12, 12, 12, 12. Now if you go to router 11, Now we'll see two routes are there, and these routes both time preferring they are preferred actually this exit point, right? Likewise, let's go and check this thing in the other router. Just to save our time, I'll go and use the. Now for router number 12, they are also receiving 11 and 12, which is the preferred exit point, router 102. So from this direction, he is learning the route, and from this direction, he is learning the route. Now you have the capability or the power of the capability and the power of this route selections and path selections, that you can go and influence the route from one place to other place. That we will see. That we will see in couple of minutes. But you can understand that how we are receiving the routes, right? So we are creating some routes here, and it is preferred. So this router is preferring this direction. This router is preferring this direction. No problem. That's okay. Then we will influence and we will see. So here we'll see that all configuration. Now, if you have to go and configure the local preference, you will see that local preference where we are applying in which direction, inbound direction, right? Inbound direction, it will influence the outbound traffic, just the reverse. So I can go to my neighbor. Actually, I have to do the configuration in router number 11. I can go to router number 11. I can go to my neighbor, and then I can influence these traffics, right? But here you can see that we are creating some route map as well. So I can go and create the route map and apply it. So let's do that. Let me show you what I just wanted to do. I just wanted to reverse the logic. That means I want to prefer this route. This route should be the best, valid and best. So let's go and create one route map. Route map and then the name you have to give. What name should I give? Any name you can give, say prefer AS 300. See, this is 200 and this is 300. Prefer AS 300, that's the name. Set the local preference 999 and then the router BGP 400. We will go to router BGP 400. We'll see that what are the neighbors. So we have the neighbor. I have this neighbor and this neighbor. See, you know one thing, that by default, what is the local preference? I should have the connectivity like this, so I can. I don't have direct connectivity. Like if I have connectivity like this, then it will be easy for me to go and change the value. Now the routes are coming to this router and this router, right? That's little bit like our topology, little bit complicated. And it will be nicer if I have something connected here as well. I'll tell you why. Like if I have one router connected here, this. And this router, if they are getting some routes 11 in this direction and this direction, then I can go to router number 11 and 12, and I can influence the local preference. Why? Because you know that local preference is applied within the AS. So then this particular router, it has the selection criteria that it can receive the routes from router 11 or router 12. So this 11, 11, 11, 11, 11 dot 11, it can be received in this direction or this direction, because local preference, where you are applying within the AS, it is useful within the AS. Since we don't have such type of diagram, what we can do, we can do that. But better if we have such type of diagram, it will be applicable. Now, since I have such type of diagram, then what I can do, that I can influence the route that is coming via this direction, in this direction, right? So what exactly I want? I want that the route that should be preferred in this direction rather than this. So router 11 should learn the prefix in this. So I should go to this particular router and influence the routes here. So my choice of the router is okay, but I will show you all the variations. Let me quickly go here to router number 12. And I can create this. Set local preference, for example, anything more than 100. Router BGP 400. What is my neighbor? So my neighbor is this. Route map. What's the name of the route map? And right now, if you go here and check the so this 11 and this 12, they should be coming in this direction. So your asterisk and greater than should be on top, not the below. So what I'll do, I'll go and do the BGP clear IP BGP star, which is not recommended. You should do the soft reboot that we have discussed earlier in previous session. So since BGP is slow to converge protocol, it will take time to converge and provide you the best path. Still it is converging. It will take some time to converge. We'll wait. And here also, if I go and check the route, so now I can see that we are receiving the route 2 prefixes actually from 102, 102 at the moment. Still it is in convergence. Yeah, you can see local preference has been set here.
Gonna waiting for so long?
Yes.
300.
Spoke. You're gonna wait there more than 5 minutes?
And as per our configuration, what is our configuration? So you can see that we have set this, and what's our show route map. Setting this like this. Now we can see that this was the same thing earlier. You should have changed here. Oh, so still it is preferred because it is telling that the local preference here is unknown. So let me do one thing. Let me go to that section route map. Hmm. For example, I'll go here, set 50 for example, and then section BGP. My neighbor is this route map is this N and USB. It will not do automatically. You need to reset this. And let's see. Now you can see the local preference has been set, right? 50 and 300. 300 I am receiving from the router 12, and then 300, and then 50 myself I set to router 11, and router 12 I have set 300. It is still converging. Then you can see this greater than sign, that is the best. At the moment both routes are there in the routing table. AS path is the same. You should give some time. If I go here and check for it, for this side it is okay. Now here also I can see that local preference has been set. This is okay because earlier we have the same thing, 202. 102 is the AS 100 router. This side now you will see 50 is preferred. Wow. So it is not working actually. Still I can see that although the local preference is less, we know that the formula is that higher is better. So this having more weight is still it is preferred. Okay, no problem. This is not related to that local preference configuration and all. I will explain you this thing in a second. I said BGP is something that is big protocol. There are so many things you need to understand. So this is the neighbor, right? 300. Hmm. GPS down. Take some time to converge. Allow him some time to converge. But yeah, you can see this got changed. That is good. That is okay.
So, question, Ranesh.
Yes, please.
So you need to have all the routers that are in the same AS with the same configuration, with the same local reference configuration.
Um, Within the same AS, that is true, but with the same local preference configuration is little bit tricky. So for example, in our case, for example, we have two routes, right? 11, 11, 11 and 12, 12, 12. And I told you that the example will be like this, that you should have one more router connected here. And then you want to send the routes to this router. And then you have your internal infra. Now, in such cases, what if I want 11, 11, 11, 11, and then 12, 12, 12, 12. So actually we want to load sharing as well. So I want 11, 11, 11 only get preferred in this direction, and 12, 12, 12 preferred in this direction. So in that case, what you can do, that while setting the MED value, or by setting the local preference value, when you apply the policy here, you can give this 100. By default it is 100, and then same way 12, 12, 12, 12, you can give value 50. Likewise in this direction, 12, 12, 12, you can give value of 100, and 11, 11, you can give value of 50. So that means this direction this will be preferred, this direction this will be preferred. Like that we can do the load sharing as well within the route map policy. I will show you that within a second. I can see. Oh, this is okay. Still it is preferring this route, because actually I should have one router here, then only the effect will come. So you will see this router is doing like this. Anyways, the logic that I explained you, this is something like this. Route map. When you are creating the route map like this, here, even before creating the route map, you can create IP prefix list. IP prefix list, 1 second. IP prefix list, prefer 11, sequence 10, permit say 11.11.11/32, and then 12. Then you go to the route map and then match IP prefix, match IP address prefix list, say PRE11, and then set the local preference, for example 500. Then you will create one more statement 20 and match the 12, and then set the local preference, for example 200. So now you can see that we are creating the route map where this particular IP, what is this 11.11, setting high local preference, and then this particular IP setting low. The same logic In a reverse order, we will use to router 12.
Well, okay. Yeah, got it.
So this direction 11 will prefer, this direction 12 will get preferred. And then if you go and see the routes here, you will see that yes, the next hop best path in this direction will be this router, and for 12, 12, 12, this will be the best path selection in this direction. Same logic true for MED as well. You will see here the MED, but the direction is out. We are applying it in the outward direction to influence the inbound traffic, the incoming traffic, right? So here you can see, and you know that lower is better. So why not try this MED in the same setup? We have same setup here also. We can go and apply the MED. I have the prefix list. So let's apply it to router number 11 only. And with the same prefix list, I can go and use it. So say route map, MED, say prefer 11 or MED 11, any name, permit 10. And then the match statement we have, and the set MED metric 50, router BGP 400. What is my neighbor? 192.168.200.101, and then the route map out, clear IP BGP asterisk. Take some time to converge. It'll take some time to converge. And section route map. Now you can see the route map. So what we have done, we have created one more where we are using the prefix list and setting the lower MED. Actually, default is 0. So if one side, for one prefix, if you are giving 50, use other prefix as well and give some 100 or maybe less than 50. It's up to us that what exactly we want to prefer in that particular direction. So now if next time I have to go and do any changes, I will not go and do any changes in the BGP configuration because BGP is already applied. So I can go to the sequence number. I can go here, oops, and set the metric, for example, 100. And this will be applicable by mistake. I give this line, but 20, I should go and remove this. Oops. Okay, no problem. You can do no. And then see the route map. Yeah. So like that, we can go here, use the other statement. I can go here, use this statement and set metric, for example, 200. So now you will see, and the route map as well, route map and BGP. So here you have the route map permit 10 and 20 related to MED, preferring this route over this as per the MED, and we will reverse the logic in the router number 12. So it will influence, since you are applying this to the outward direction, it will influence the incoming traffic from ISP across the, this validity is across the ISP. Since this is in the inward direction, this will this will be applicable for the outbound traffic, but within the AS. So that's the logic we have. Clear IPBGP. Actually, I'll just clear this and will provide some time. Meanwhile, you can go and have a look on the these documents. It is only 10-page or 11-page document, but I have added everything, all the important information related to path manipulation. For path manipulation, we are using MED and local preference only. Plus AS prepend is also used. So these three are used in the production network. Either people will go and use MED, this will be heavily used, then local preference, second option, and third preference is path prepend. So you want to learn the route from this path or this path, you can do that. I will show you that as well after few seconds. So you can go and have a look on this. Let's go back here and see the changes. Still it is not converged. That's good. 102. That's good. I can see the local preference 300, 200. We have changed that, right? Section. Route map. It is coming from other side. 300, and there we have put, I think, 500. Come on. This is good. This is good. And if I go to switch number 101, let's see. Do we show IPBGP? That's okay. Receiving the route in only one link. And this will also receive the route in the one link. That's good. That's okay. Now, let me show you one more capability here related to path prepend. So in router number 11, clearly you will see that this is coming via how many hops? This is coming via 2 hops. This is coming via 2 hops. Let's see. Section BGP, the power of path prepend. I can go to this particular. Okay, let's go one by one. I can go to BGP, and then I want to make this as a preferred. So this route I will make as a less desired route, right? So I can go here and I don't think so that we have here. I should apply this in the route map only. I should do this in the route map, no problem. Section BGP, let's see the policy. And I will remove this policy. Say route map is, for example, path permit 10 and set is path prepend, for example, 555, 555, 555, 555, and then router BGP 400 Let me remove this first of all. And then AS path, right? Okay. Mhm. See that changes will happen. It's got prepended. And you know that this is the bad option. If we have these many prepended, so less number of A's will be preferred, not the more number of ASs. Once it will get converged, you will see the result as well, which is the best path from where we are doing getting the best path. So what we have done that for router number 11, this path that is coming from AS200, we have appended different ASs like AS555 3-4 times. So that means that this path is not a best path because it is coming via more number of autonomous system. So that means that the path that is coming via this direction, this should be the preferred path because here you have added prepended more number of ASs. AS. You can see still it is showing you the best path because we have some other route map configuration as well. I should go and remove this, but I need the neighbor. That's okay. This got removed. And then I should go and section BGP. Section BGP. And let me do one more thing. Final command. My neighbor. Let's do this thing. This actually next hop. One zero to not this one. Actually, I should have this neighbor. I can see that. Okay. Then BGP asterisk. Yeah, you have any question, please feel free to ask. We're almost done with the path manipulation options that you have the MED option, you have the local preference option, and then you have the AS prepend option. All these options you can go and utilize to select the BGP best path.
Okay. No, I don't have any question.
All right. So we have reverted back all the configurations. Once it will finally converged, we'll see that result. Meanwhile, it is converging. Let's go back to the agenda that we have. So what we'll check next time, that is this is a little bit a more advanced topic used within the ISP. In our topology, we have an ISP topology as well, where we have the 5 routers connected to each other. Router number 1 and 2 in backbone, it is connected with router number 3, router number 5, and then router number 2 is connected with router number 4 and router number 6. So there we'll go and enable the BGP, and there we can go and do the configuration related to route reflection. Your task is this, that you have only 6-7 slides. From your side, you just try to go through it. You can see that oh, I have added the configuration. I'll show the route reflection configuration as well. I have added some configuration related to community as well, but community is something that is a little bit more advanced. But just in case that you want to know about that, I have added multipath and the community configurations as well, that we will see in the next session. And after that, our CCNA DevNet will start. So next week, our CCNA DevNet will get started.
Okay.
It has some issue, but generally this, yeah, you're right. So you can see now, no issue. It is showing correct result. You can see that more number of hops, they are not best path. You can see router number 11, 202, this IP, 101. Where is 101? 101 is this. Earlier in all the use cases, you can see that this was the best path. Now, since it has more number of A's, so it is referring the router number 12 to learn the route, right? So now the preferred is not this one, because it has more number of ASs. The preferred is in this direction. You can see router number 12 is the preferred. So yeah, this is good. All right, so let me pause here. Tomorrow thanks for joining. Today is our day number 4 for BGP. In this list, this is day number 3, but we are in day number 4. We are going to discuss few of the advanced topics related to BGP, such as configuration, route reflection, multipath, graceful restart, scaling technique, IBGP full mesh challenges, and others. Mostly these things are applicable to ISP. From the customer side, what we want to do, that our in customer premises, we have CE router, customer edge router, and that CE router will get connected with the PE router, provider edge. So that C to PE configuration, generally we are doing some sort of redistribution from IGP to BGP, BGP to IGP, and then we are applying to the neighbors. Like that configuration we are doing. In case if we are working within ISP, or in case if our own AS is big, there we can go and apply the configuration or route reflectors techniques that we will discuss. So let us discuss these technologies. This is the topology that I am going to cover today for our route reflection client. And this R3 will work as a route reflector, RR. So what's the use here? Basically, this topology is taken from one of the ISP backbone that we are going to utilize today. Assume that this is one of the ISP backbone, and this ISP, this is the nothing but the provider edge router, which is connected with the customer premises, customer edge router. So router number 11 in our topology, or maybe router number 12 in our topology. If you see all the previous topologies, router and 11 and 12, they are connected with this MPLS backbone. This is some sort of ISP number 1. This is ISP 1. So router 11, router 12. So these router 11 and 12, their significance is that they are working as a CE, customer edge routers. And over these interfaces, you have multiple, actually these interfaces, these routers actually, you have multiple VRFs, customer VRFs. So these interfaces are part of unique VRF. So from ISP, the routes can be exchanged over this interface within the VRF. So the ISPs, they are building the customer wise, they are building the VRF table or routing table. Each customer, they have independent routing table or virtual routing instances, because interfaces are segregated into different VRF. Now in this topology, obviously these devices, they are working as a PE, provider edge, within the backbone. They are the PE, provider edge, within the backbone. But the device that you can see, R1 and R2, they are working as a provider, P routers, and they are termed as a BGP free core. They are not running BGP. They are free from BGP. So core is free from BGP. But these devices, you can see the provider edge, they are running the BGP. They can go and run uh, different type of address families like IPv4 address families, IPv4 address families with VRF, IPv6 address family, IPv6 address family with VRF. They can go and run the VPN v4 address families as well. And since we want to make this router as a route reflector for IPv4 address family, IPv6 address family, VPN v4 address families, etc. So all these devices, they will get peering with the route reflector. You will see in the configuration in route reflection, we don't have individual peering. We don't have peering with the devices each other. We don't have this peering, but all the devices, they will go and get peered with the route reflector. So the peering, BGP peering, the BGP IBGP peering will be like this. Will be like this. And you don't have individual peering. You don't have this peering. You don't have that individual peering. Why? Because you want to save the control, BGP control plane. If you have full mesh topology, if you have unnecessary BGP peers, then it may cause some issue in terms of optimizing and scaling the BGP. So you can see that either you can go and use the confederation, or you can go and use the concept of route reflection. We'll see one by one. Yeah, route reflectors. What is confederation? Is nothing but a big AS you are breaking into a small AS. And since they are part of a small AS, we know that different autonomous systems, they are forming the eBGP relationship. So if you do that, one big autonomous system, they have a small autonomous systems. These small autonomous systems, they will go and form the eBGP relationship. So obviously it will go and uh, provide the we can say that prevention from loops. By default, if you have one big autonomous system and all devices having peering with other all, there may be chances that they can go and have routing loops. But if you can go and divide a small ASs, we know that we have AS path attribute that will go and protect from the routing loops, etc. So this is one of the mechanism to optimize plus to protect from routing loops. Likewise, we can go and do the route reflectors. Route reflectors primary and secondary you can build. Again, this will go and reduce the number of peers, the number of IBGP peers, and it will optimize the performance to the routers. So these are the optimization techniques we have. Then obviously you want to use the multipath. Why? Because you don't want, suppose one router is connected with two ISP. You don't want that all the time one ISP is primary, another ISP is a backup, and you are not using the other link bandwidth. So in that case, you can go and share the load. You can use the concept of multipath, right? Okay, and then graceful restart. What is that graceful restart? We have done some hard restart. We have done clear IP BGP asterisk in our previous session. Those are nothing but forcefully restarting the BGP. But we have one feature called graceful restart that will enable routers to continue forwarding the packet while BGP process is starting. That means you are restarting the BGP control plane, but BGP data plane, there is no impact. So you can go and use the graceful restart feature within the BGP. Now, why we are using the route reflections or confederation? Because if you have full mesh topology, then your complexity will be n into n minus 1 by 2. That means, suppose if you have 10 routers, your complexity will be 10 into 9 divided by 2. That means 45. That means just with 10 routers, you are managing 45 BGP sessions. That is huge. That is not optimal. So in that case, what you can do that you can make one router as a primary, as a RR, and rest of the routers will go and create the BGP relationship with that particular router. So your complexity will be very much like N. So if you have 10 routers, then your complexity will be 10 only. In full mesh, your complexity is 45. You're maintaining 45 sessions, or you're maintaining 10 session. Obviously maintaining 10 session will be less process intense, and it is the optimal solution. Configurations like AS within AS we are doing for the BGP large scale deployments, yes, because if you have big BGP infra, basically that is in ISPs that they are maintaining big infra, then they can go and create the AS within the AS. Then BGP is used, actually the MP BGP flavor of BGP is used within the ISPs to connect different type of customer as a CE to PE connectivity. And there are different type of protocols that is running in between the CE to PE that you can go and enable. All right, then we have this route reflectors configuration. Even I have one configuration related to community, just to show that, yeah, you can go and use the community as well. I will show you the route reflection configuration in the lab. And yeah, you can set the community. We are sending the community. There are actually different use cases related to community, BGP community. BGP communities are used to group routes and apply policy based on these groups. They are the tags that simplify the policy implementation. ISP use communities to control route advertisement, set local preference, manage customer. These are nothing but the tag, and it is associated with the policies. Yes, import and export of the policy, route exchange of policies from the ISPs to the customers, and with the tag, it is actually easy to manage those policies and route exchange. That's why we are using it. So why not? Let's go to the lab and let's do the configuration related to the route reflection. Here you have. So the same topology that you have 1, 2, 3, 4. Where is router number 5? Let me connect router number 5. Somehow it is gone. Oh, okay. Let me pull that. Why it is? Let me pull it back. router number 5. Okay, so what we want to do, these routers, first of all, you should have some IGP running. That means some OSPF or something will be running. So I can go to the interfaces range, say loopback 0 and E0/0 as per the topology. IP OSPF1 area 0. And likewise, this router as well. Router 1. These are the backbone routers. IP OSPF1 area 0. Let me quickly draw that diagram on the top. Oops, color should be changed. 1, 2, 3, 4, 5, 6. This is router number 3. This is router number 4. This is router number 1. This is router number 2. This is router number 5. Router number 6. And then the connectivity. So router 1 and router 2, 0, 0, 0, 1, 0, 2, and then the loop back. And then again router number 2, E00, E0102. But all these interfaces that you can see, this router 3, all these interfaces are E0/3. All these interfaces are E0/3 that is going towards the main router. That's the topology we have. Then I can go to router number 3 because first of all we should go and enable the OSPF. We should have some IGP. E0/3 and then E0/3. E0/3 interface loopback 0. They have some loopback addresses and they are also part of OSPF. 100.255.254.6 2/32. There is one loopback address problem in router number 4. So if you see router number 4, this IP is wrong actually. We have to correct it. IP is correct, but the subnet is wrong. It should be 255. Rest everything is okay. So this is our IGP that we are running to show IP OSPF neighbor. Let's see that neighbor. So you can see that router number 1 having 3 neighbors, obviously 3 connected neighbors, R3, R4, R2, 2, 3, and 5. We are in R1, R1. Oh, 2, 3, and 5. 3 is okay. Oh, actually, this diagram is little bit wrong. It should be R. Okay, let me correct it. Diagram is okay. The number of the router placement that we have. Actually, this is actually R4. So 3, 4, and then oh right. No, this is R. Actually, this is not R4. This is actually R5. So 3, 5, 4, and 6. This is actually R4 and then 6. I can go and I can correct the naming. Let me correct the naming. Oops. Okay. This is R number 5. This is router number 4, I think, and this is router number 6. And this is obviously router 1, and this is router number 2. Like that, we have the naming, and the rest of the things are same, connectivity and the interfaces and all. But this is the correct topology. Okay, great. So now I can go to router number 2, check the neighbor. You can see 146. 146, that's correct. Router number 3 should have only one neighbor because it has one connectivity. Router number 4 having only one connectivity with R2. Router number 5, having one connectivity with R1, and router number 6 also having one connectivity with R2. So our IGP is good, it is working fine. Now what we want to do here is this, that we want to create the route reflection configuration, right? And R3, so R1 and R2, we don't want to enable any BGP. R1 and R2, they are BGP free core. So we have to enable BGP within R3, R4, R5, R6. So let me see that if some BGP flavor is running here, no BGP is running, and all the places to show run section BGP. Few places I can see BGP is running. What's the AS number? 10,000. Okay, so I will go and use this. Some of the configuration is there, some of the address families are there, some of the communities are there, some configuration is already there, right? Anyways, we'll go and do our configuration, but in this configuration you can see that all these configurations that you are seeing here, actually I don't want these configurations and all. So I'll remove this configuration. We'll create our own configuration. I don't want this complicated configuration. So no router BGP 3.4. Router 3, anyways, you don't have any BGP. Router 4 also I'll remove. Router 5 we have removed. Router 6 will be removed. So now we don't have BGP running anywhere. Now I will go to router 1. Let's do the configuration. Router BGP. So, sorry, no router BGP. This is BGP free core. Here we don't have to enable this. 1, 2, 3, 4. Let's come out of this. Yeah. So we are going to focus on R3, R4, R4, R3, R4, R5, R6. These 4 routers, right? Where at the moment you can see nothing is running. Now, what we can do here is this. Let's go and enable BGP. So first of all, route to BGP and the AS number. Now I can go and use the neighbor command. So we will go and do the normal configuration of BGP. Later on, we'll go and add some specification in that related to route reflection. Remember that the router number 3 that we have, right? Router number 3 that we have, it should go and form the BGP relationship with all the other devices, but other devices should only form the BGP configuration only with router 3. So what I'm telling here is this, that here the neighbors.
So router 3 is gonna be like the primary.
Yes. So interface loopback 0. Show IP interface brief. Loopback 0. Let's see. This is the IP. So neighbor command I will use 100.255.254.1. router number 4, 5, and 6. So 4. And the same remote is, then up date source loopback 0, right? Likewise, 4, 5, and 6. 5, and 6. Oops, it's telling that do the remote command first. Section will, I can see the configuration. Right, now we'll go to R4, for example, router BGP 1, 2, 3, 4, neighbor 100, 255, 254.3. This is the normal configuration that we are doing, right? But what we want in this configuration, we want to make R3 as a router reflecting server, right? We'll do that. So 4, 5, 6. I think I need to go, and this is the old output seems, because 4, 5, 6, 5 and 6, we are not running BGP. So first of all, clear this. Still, I'm getting some information. We are not running, right? There's no BGP running here in 4 and 5 and 6. So why I'm showing this? Just now we enable here, which is in active state. Assurance section BGP. Assurance section BGP. Clear, right? BGP star. No BGP is running. I don't know why this is some error related to EVNG. It should not show anything except with one of the router that we are configuring it. But anyways, no problem. Let's do the configuration. I'll come back to that. That's the BGP configuration. So this configuration, I think it will be same here. And this will be the same here. And now we'll allow time to BGP to get synced. Now you can see idle, active, open send, open confirm. Those are the messages that we have. Show IP OSPF. Okay. That's fine. Let me see that it should not running. Should I be BGP? Should not run BGP. Router 1 and router 2 should not run BGP. They are running only. That's very good. Should I be route? They have all the routes related to one. The loopback addresses. Perfectly fine. And then let's see. So I pin. So now you will see that they are not coming active and all. You guess what's the reason why it is not coming like this?
No, not sure why.
This is the interface that we are enabling the OSPF in area 0. Sure, section BGP. Let's see. Address family. Five four two five four dot. Suppose for summary. Let's work on just this phone number. IPv4 255.254.3. I'll tell you why this is section BGP. Let's check the BGP configuration. By default, what is happening actually that these BGPs that they have the default address family. If you are working on normal router and switches, then the default address family will be IPv4 by default, right? But when you are dealing with ISP routers, then you have to go and define different type of address families, like address family VPN v4, address family IPv4, IPv6, etc., etc., etc. So once you do this such type of configuration, after that you should go and activate the you should go within the address family and activate it. Otherwise, they will not work. So likewise, in this case, we are enabling the address family IPv4, and now it should exchange some packets and it will try to work. And this is actually the service provider setup where we are assumed to enable the MPLS configuration over the interfaces, and then we should go to VPN v4 address family, and then we should go and enable the configuration. Because since we are in the CCNA class, so I'm not going into that complexity. Simply I'm enabling this configuration related to IBGP. Anyways, IBGP relationship should work. There is no point that it should not work. It should work. And we have seen this issue earlier as well, that while doing this update source loopback, it was not working in the normal connectivity. So I will add little bit more complexity here, and then we'll go and remove this complexity. So for example, if I go to address family VPN v4, And then if I go to the neighbor, activate section BGP. I'll tell you what are all these things. You can see community is also got enabled for this. And if I go to address family, and show IP BGP summary, all summary. Now you will see here that when you're running this command, show IP BGP all means all the VRFs summary. Then we have this IPv4 address family. You can see different type of address families, IPv4 address families you can see. And then you can see this VPN v4 address family as well. So this is one of the command that will go and tell you about all the different types of address families, all different type of VRs, everything in the output will come. Now one more thing I want to do here is this, that I want to go to this neighbor, for example, and I want to enable the route reflector client. I want to go to the neighbor number 5 and neighbor number 4 as well. Likewise, I'll go to address family IPv4. So you will see the variation here, not only with the IPv4 address family, but with IPv6 address family, with VPN, v4 address families as well. You can go and enable the route reflection. That's the beauty we have with the BGP. This is the normal configuration, but then we are going within the address families. Not only we are activating the neighbors, but we are enabling the route reflector clients as well. Likewise, I can go here to the address family IPv4 and I can go and activate the and do show run section BGP. We can take the entire configuration because this same configuration is true for R5 as well, and same configuration is true for R6 as well, because they have to pair with only one of the speakers or one of the route reflector server. All summary. Configuration is correct. I will go and remove the loopback thing. Since loopback is doing some issue, we will check that. Right? But this is the configuration that we have discussed. I will go and optimize this configuration a little bit more. I'll come back to this configuration. Let's quickly see the theory that we have. Just 4 or 5 lines I have added for your reference. While you are creating the route reflection client, I have added this use case as well. There's a scenario as well in this. In the topology, AS200, 300 may have a specific peering arrangements. It's okay. You can see that I'm going to one of the router, switch 1, suppose BGP route reflector switch 10. Suppose switch 101 in our topology, the previous session, we have different topology. So in that switch 101, if you want to make this as a route reflector, then you can go to switch 101, then their neighbor, tell their neighbor, I am the route reflector client, tell the neighbor, I am the route reflector client. So all the neighbors, we are telling it. And by default, this is the address family address family AFI or sub address family interfaces. This is IPv4 address family. You can go and do this configuration. The rest of the devices, they have to go and peer only with these devices. That's it. So the configuration wise, you can understand that no problem in the configuration like that. You can go and do the configuration. Since I haven't enabled MPLS and all those things, not coming up. So what I will do here, I will go and remove few of the lines related to like this. Neighbor update shows maybe this is causing problem. And let's go to one of the router here. Neighbor 254.3 updates. Let's see. Quite a strange. Summary. Section BGP. Okay, let's do one more thing. We are in router BGP. Run. That's good that we are doing some troubleshooting as well. BGP router ID 100.255.254.3. Let me add the router ID as well. Oops. Should be added here. And this will be 5. And this will be 6. And I'll go here and clear IPBGP as just show IPBGP summary. Still bit strange. BGP should come up. I don't know, maybe some UNG or something. Breaking here. But yeah, so far the configuration you are able to understand. I'll try to bring this up with the MPLS configuration and the remaining configuration that we don't have. I'll go and add those configuration. I will see that why it is not coming up. It should come up. These neighbors that you are seeing, they should work. All summary, right? All summary. So they are showing idle. Let's do one thing. Clear, debug the packet. Let's see. Debug IPBGP. And let's see why exactly they are not forming the neighbor relationship.
Refused by remote calls.
Yeah, they should, because this is a very simple thing. BGP should form. Local address is this. Some issue they have, some packet exchange. Local address 100.0.13.2. Let's see. Do back 0. Let's see that I'm able to ping. Other side, IPs or not. These are the destination. So I have the IP reachability. Oh, I don't have with the router number 5. With 4 I have. With 6 I have. But 5 is failing. Why is failing? Sure, an interface loopback. Let's see the loopback address. Oh, IP OSPF 1 area 0. Ah, now I'm able to reach to router number 5 as well. Good. It is trying. You can see that it is trying. It's telling that some BGP is active or TCP is not available. Open active delays. When it is trying to form this session, the TCP session is not forming, and constantly it is throwing error. Constant. You can see going to active to this. No problem. I will do one thing. I'll go and do the full configuration. This is not the full configuration actually. I have to go and enable or disable some of the things here. So I will do that. Let's try to bring this up. Actually, we have to enable some MPLS configuration. We can leave that part. Working on that. And then interface. What are the interface? Range E0/0 to 2. And is point to point and MPLS IP. Just ignore those configuration. Interface range. What range we have? E0/0 to 2 and IP OSPF point to point and MPLS IP. Like this. Then router number 3. Our interface is 03. Point to point. Okay. Back 0. We have IP OSPF 1 area 0. This is not required. Okay, I'll just try to bring this session between router 1 and maybe router 6. IP and router summary to show IP BGP all summary. Okay, I'm just trying to bring this session between 6 and 1. no route to peer or no route to peer. Okay, I can understand, but I just wanted with 1, 3 and 6. I don't want with 4 and 5 because 4 and 5 I have done the configuration. Let's do this. LDP router ID loopback 0 force and interface E0/3 IP OSPF network point to point, and then the MPLS IP. That's okay. OSPF is up and running. Loopback 0 IP OSPF 1 area. So make sure that it is in area 0. So this final configuration. Here's LDP. Router loopback 0 force. Interface E0/3 IP OSPF network point to point and MPLS IP interface loopback 0 already is area 0. Done. So I have done all those. Show them. BGP to show IP BGP summary, and then let's see BGP. So now we have done. Fail. Still it is fail, no problem. We can go here, and since all the loopback addresses are reachable, so we can add that in the configuration. To show IP BGP summary, to show IP BGP summary, all summary. Something is happening. You see,
It's up now.
it is coming slowly. It is coming up. Open send, open confirm, and all those things. Because I told you earlier, this is something like ISP network. So I need to go and enable some of the capabilities related to ISP. But we don't want to enable MPLS. It should work. If I go and make the network, OSPF network point to point in between, and then the loopbacks are not advertised, seems in BGP. So if you do those configuration, it will work. But you can see that all those address families are working fine. Somehow this MP-BGP now kicked off, and the address families are coming good. It's showing good. So since it is up here, obviously here also it is up. They are up, right? Now likewise, if you want to add some more complexity, you can add, but again, I don't want to go beyond that label that we are studying. Even I can go IPv6 address family as well, enable that. I can go and use some templates or BGP listener or peer groups and enable it. For this point, this is okay at this point of time. We are good with this.